Welcome everyone to the February webinar. Today we're talking to McGee Young and Steve Suffian. They are both PhDs, so this is the first time we've had two PhDs speaking. And what's really funny is, so Steve Suffian, I'm sorry, your PhD is not impressive. It's electrical engineering PhD, and you know those guys are a dime a dozen on this podcast. But McGee Young is a political science PhD. Now that is different. We don't get those kind of people very often. So these guys, they used to work for Recurve, and Recurve was really, I think, I mean, maybe I'm wrong and they'll correct me, but I think was the leader in NMEC, which was option C, M, and V for utility programs. And maybe still is, I don't know. And they worked there until I think it was 2021. Does that sound right? And then McGee went and started Aristotle Energy, which then I think morphed into WattCarbon, which is what both he and Steve work at now. And I guess I will let you tell. They will just tell them. They will describe themselves better than I can. So I'm just going to stop talking and I'm just going to listen to this webinar. This is going to be great. So go ahead, you guys.
Thanks, appreciate you having us on and everybody for taking some time out of their day. I'm McGee Young, the founder and CEO. Steve and I have been working on measurement and verification challenges for almost a decade now, thinking about how to automate a lot of the work that goes into doing M&V with the ultimate goal of creating more robust demand-side energy markets. There's a lot that goes into it. We've gotten more wrong than we've gotten right over the years, I think. But I think slowly but surely we've made some real progress and being able to kind of create the infrastructure that would be we need to be able to scale this side of the industry. Both of us are going to spend some time today talking through different parts of this. I'm going to talk about why we need to be able to scale M&V in the industry. What the implications of automating M&V are. A lot of you, I think, are probably professionals who do a lot of this work manually and understand why you need manual M&V in a lot of cases. And so really trying to get at some of the tensions and trade-offs between manual and automated M&V. Steve is going to talk about how we do it. He'll flip it back over to me to talk about, again, some of those limitations, what works, what doesn't work. And then, our kind of perspective on the future where all this is going. We'll have time for Q&A at the end. If there's questions that you have that come along the way, feel free to pop them in the chat. We'll make sure we try to save enough time to be able to have a conversation. So let me start, with what we think of as the scaling problem. There's something like 1 billion machines that are going to come online over the next decade or two, and most of them will be connected to the grid, and most of them will be valuable for balancing the intermittency of renewables, the rise of data centers, all of the electrification of our economy. And so as we're thinking about the evolution of our grid infrastructure, distributed energy resources are an increasingly important part of that puzzle. Thermostats, obviously, like the most ubiquitous, but we're seeing, EVs now, batteries, solar, all, there's many more to fill out this chart. All sorts of energy efficiency types of projects are all what we would call distributed energy resources, and all contribute to making sure that we can distribute power where it needs to go, when it needs to be distributed, with some socially beneficial goals in mind. Lower bills for consumers, more efficient use of our infrastructure, and at a macro level, trying to do this with minimizing the use of fossil fuels. And so DERs are becoming a really important part of this landscape, but in order for them to be valued, they need, for the most part, some form of measurement and verification. For something like rooftop solar, it's not that challenging. You put a meter on the solar panels and measure how much they produce. But if it's something like energy efficiency project or a demand response where you're calculating a counterfactual, now all of a sudden M&V is a much more critical part of this of the story. And how we do that M&V is going to be really important for achieving that scale. I know, again, y'all are sort of used to this. Thinking about the work of doing, kind of traditional project-based measurement and verification, there's a lot that goes into it. You're gathering historical data, you're cleaning it, normalizing it. Everybody knows that utility data is, not the easiest thing to work with. You're building baseline models. You're doing that kind of post-period analysis. You've got non-routine events. You've got to talk about, what adjustments that you're making. There's a report that typically gets written. So I don't know. I was thinking about, what's the kind of average time per project. Even if it's an hour, we've got millions of projects needing M&V, and we do not have millions of M&V professionals. So at some level, we're going to have to figure out how to scale the work that we're doing. Why does this matter? So right now we're seeing, the largest increase in electricity load, probably in history, occurring over the next, 5 to 10 years. So data centers, some of the math on this is really just incredible. It's hard for us, even us who are in the industry, to like wrap our heads around the scope of, a single data center being equivalent to the, consumption of a mid-sized city. We're building, dozens, if not hundreds, of these data centers now, and so we're really, our own ability to sort of fathom what's going on is almost like beyond human scale. And then the value that's come, the revenue that's generated from these data centers is also sort of mind-boggling. To put it into some context, a rough number that I've seen used a few times is that a typical data center will earn about $1.25 in revenue for every kilowatt hour that it consumes. So, consumes kilowatt hours to do its, algorithms and whatnot. And each kilowatt hour nets $1. So if you're paying, even 50 cents a kilowatt hour for that power, you're just minting money at that point. So the race to get access to kilowatt hours or to capacity to kilowatts is amongst the most intense that we've ever seen. And for the most part, data centers, utilities are turning to traditional sources of power. They're putting in, new gas power plants. They're restarting old coal and nuclear plants. They're taking jet engines and strapping them down next to a data center and running them to be able to generate power. And so right now is the opportunity where DERs actually have a really huge role to play in becoming part of that power equation. But if we can't measure it, nobody's going to trust it, and utilities aren't going to value it, and data centers aren't going to be willing to pay for it. And as a result, the hundreds of thousands of millions of buildings that could be good candidates to participate in virtual power plants or to do energy efficiency get left on the sideline, and bills continue to go up, and climate change continues to get worse. And so we need to, create the infrastructure that allows for distributed energy resources to compete with larger, power plants, utility scale projects. And that's kind of the work that WattCarbon is trying to do now, is to create that automated infrastructure that allows for DERs to be part of these new markets that are emerging. So as we think about, automation of M&V, there's some pretty significant changes that have to happen as we move from spreadsheets to software. And with traditional M&V, we're just limited in the amount of time that we can spend on these, and so we'll typically do them once in a while, maybe annually, maybe semi-annually, mostly on a project-by-project basis. Often, almost entirely this is done, within spreadsheets or maybe some Python notebooks, but generally we're, kind of creating this by hand, templating it maybe if we can, but it's being done in a fairly conventional way, and it leans heavily on your you us, M&V folks, our judgment. So if there's some weird discrepancies in the data, some abnormal energy usage in the building, we come up with ways of normalizing for that in a fairly bespoke way that tries to get at the root impact of the measures that were installed. And that's going to be the trade-off here as we move from traditional into automated M&V, is that on the one hand, we'll be able to monitor the performance of these buildings on a continuous basis. We'll be able to do so at scales that portfolios of hundreds of thousands of buildings potentially at a time. But the methods are going to be standardized. We're going to have to do it the same way, more or less, over and over again. That enables real-time tracking, but instead of it, each project being at the discretion of the analysts, you're going to set parameters, and so you'll more creating guardrails around the M&V than trying to get every project, to a CVRMSE less than 0.1, or some criteria that would require a lot of finagling of the underlying data. And so this is, I think it's important for us to kind of keep in mind that we're not trying to recreate the sort of perfection of the one-off report, but rather to highlight, in some cases, where a building is not very predictable in its energy usage, just to call it out as that when we go try to understand the savings associated with a building where there's a lot of erratic energy use, you're going to be pretty, your confidence level is going to be pretty low with respect to your savings calculation. In other buildings, you'll have a lot higher confidence, and that's okay. And especially because we're going to, as we think about these as portfolios, the degree to which we're sort of less confident about certain buildings tends to, and I know the engineers in the room are going to like get the chills when I say this, but we'll be able to those errors will kind of cancel each other out. And as a social scientist, we tend to think in statistics. So from a statistical standpoint, with a larger portfolio, we can still have the same amount of confidence that the savings being recognized are there. We just are not necessarily confident at the site level for every single building. And so again, wanting to be kind of explicit about what those trade-offs are. So that a lot of the work that we do at WattCarbon, as John mentioned, stems from our previous work at Recurve. And some of you have heard of Caltrack, the OpenEE meter. These are the kind of core methods and infrastructure that we worked on back then that had been initially funded by the California Energy Commission and then open sourced through LF Energy, which is the Linux Foundation's energy division. Now collectively known as the Open DSM meter there, and it's available for anybody to download and use. I encourage you all to, if nobody's ever done it, to take a look at it. It's the kind of thing that's pretty easy to run, especially now if you've gotten into some of the AI, tools, Claude Code and that kind of thing. Makes it pretty easy to take this stuff off the shelf and start to play with it a little bit more. But this is, kind of like the core of what we do is we think about M&V from the perspective of the availability of meter data, smart meter data in particular, so we can get, hourly savings calculations. And typically, pursue one of two types of M&V strategies, a daily M&V calculation where we're looking at either daily or monthly energy data, or hourly where we can get at the, specific impacts at particular times of day. Today, this is this is pretty common now. It's the basis of most of what California does for the Department of Energy Homes program in the IRA. They adopted this as sort of the default pathway for the measured savings approach. And some of the benefits from using these types of tools is that, in theory at least, you'll get the same answer from the same data, even if you've got two different people doing the measurement. And that's been fairly uncommon. The ESCO world is that's been a struggle in the ESCO world, where you have two equally valid M&V results that show very different outcomes, and adjudicating between those becomes the source of a lot of litigation within the ESCO. And I think that historically our work has relied on a lot of like kind of secret sauce, which has been helpful in some ways, but also undermined a lot of the willingness of people just to kind of take your word for it. And so our approach is kind of the opposite, where like, and Steve will talk about this a little bit and kind of get into this, but like every single decision that gets made, every single parameter that's that we've put in to create that output is shown, so that full audit trail from the savings calculation that you get all the way back to where you started with what methodology and why you're using that methodology in the first place. And so our thinking on this is that if your results are reproducible, then your results can be auditable, and that can be the foundation for trust needed to scale demand side energy markets more generally. So again, kind of to sort of summarize that thinking, whereas we started off with traditional MNV, where it'd be kind of one-off, and you sort of have to wait maybe a year to get an updated answer. With automated MNV, you're really doing this, we run this on a nightly basis. So every single building savings calculations are updated daily. You're able to see your performance in not quite real time, but more or less in real time. And then at any point, if there's a stakeholder who needs some sort of report on, hey, how are things going? It's all right there for you without having to do any additional work. And that's extremely valuable in terms of just kind of the time savings associated with a lot of this work that gets done. We also see things failing pretty quick, and early on, stuff like, hey, why are we not getting savings here? And so being able to catch those problems early is super valuable from a performance standpoint. And then again, kind of unlocking access to these new energy markets, is I think, ultimately the upside here of what we're looking at. I'm going to just kind of talk about two quick pieces that WattCarbon is doing. So we've also built what we call WEATS, the WattCarbon Energy Attribute Tracking System. One of the, I think, really interesting ways in which we're thinking about demand side energy resources is that it's not just about the kWh anymore. We think about energy efficiency, we're thinking about some volumetric savings that would happen maybe over the course of the year. But as we get into which hour of the day those savings are happening, it starts to look more and more like a capacity value, a kW value within a given hour. And so if you're, for example, putting in heat pumps to replace electric resistance heating, and your grid is suffering from a winter morning peak problem, your heat pump might, on an annual basis, it's going to have great savings. But during those winter morning peaks, when the grid's most stressed, your heat pump is going to be particularly valuable because of the additional capacity that it creates for the grid to be able to provide power to everybody who needs it. So an energy attribute certificate, as it were, can capture both the kWh volumetric value, as well as the capacity, the kW value, as well as the environmental benefits. And so we know that these projects are also avoiding carbon emissions, and that can be part of a broader set of reporting that gets done, so that every hour, every asset is generating these energy attribute certificates that can be the source of making claims around capacity or carbon, or even potentially traded or monetized. And so there's a secondary way for these projects to make money aside from kind of traditional bill savings or rebate eligibility, that now these other values are helping to drive revenue into these projects. So I'm going to stop and hand it over to Steve to talk about how we do what we do. And then we'll wrap up with a few kind of closing thoughts on where it's all going. I don't know if I need to continue. John, I should have asked you this doing the
Yeah.
of the screen?
Yeah, that's probably the easiest thing.
Okay, Steve, you just tell me when I need to go to the next slide.
Sounds good. Yeah, so hi everybody. I'm just going to kind of walk you through how automated MNV kind of works on our platform. So the first step we really have that makes things more scalable is data integrations. And what these are connections to a variety of different data sources. So whether it's utility data providers, there's solar data providers, batteries, custom, individual device level data providers. And we built these ETL pipelines so that we ingest that data, clean it up the same way every single day, and get it into our systems. And so what that means is once we figure out what time zone the data is in, when we're setting up that connection, we have it set up for everyone, and missing data, we have shared rules across these things. And so we don't have that sort of every batch of data gets a new headache sort of problem. From the user's perspective, all they need is to provide credentials to one of these sources. So if you have a utility API token, you go on our platform, throw it in, and from there we can just fetch your meters and meter data, and you can kind of use it to calculate savings for one of the methodologies. So then the question becomes which methodology to use. And it depends on what kind of data that we find. So if you have whole building meter data, whether it's billing or hourly, whether there's sub-meter data, it also depends on what kind of intervention. So are you talking about a demand response event that we're measuring the savings from, energy efficiency, electrification, load shifting, and several others. And so based on the data and what kind of project information there is, we then will select the methodology. And where we're selecting the methodology from is a repository that we've put up through the OpenEAC Alliance, which hosts the full detailed information about how to implement a set of different methodologies. So they're categorized in two different groups. There's sort of the standardized methodologies. The one that we have right now is what McGee was talking about, the Caltrac EE Meter OpenDSM one, that's used for energy efficiency and long-term projects that require like a year of baseline and reporting. But then we have these custom methodologies. These are ones that we as WattCarbon worked with individual DER providers to create for the type of measures that they're doing. And the idea is that hopefully that these are repeatable and can be used by other DER providers, but also this is the place where sort of MNV expertise still comes into play. This is sort of still like a manual step here, is figuring out how to sort of build out the scalable methodology. And so for now we have several. There's a whole building electrification one, lighting. There we have heat pumps that have heat output sensors on them, and we have a whole methodology around that. Demand flexibility and others. And all of this is publicly documented, open to comment on the openeac.org website. And so in the next slides, I'm just going to get a little bit more into detail about how that standard methodology, the OpenEE meter one, actually works and calculates savings. So to start off, McGee previously mentioned that there's sort of two flavors of this methodology. There's a daily model version and an hourly model version. So the daily model version is typically used when the data that you have is either bills or it's daily data. And of course, so like in some places in California, you can get daily gas data. And the way it works is you pull a year of baseline data before the project took place. You take the daily temperatures from that specific site where the project took place, and you build a piecewise linear regression where you're figuring out the balance points, both a heating and a cooling balance point, if that ends up being available, and then slopes, so that you end up capturing the temperature dependent load in your predictions. And so this chart is sort of an example of in the baseline period, you had temperature and energy relationship that looked sort of like a little L, and you can see that it lines up pretty well with the colder it is, the more consumption was being used, and so that slope represents sort of your building's relationship between temperature and energy. And then what we do is we build this model out using your baseline data, and then we use it to predict based on reporting period temperature data to get a counterfactual of what your building would have used if you hadn't done the project. We then subtract those two and get savings. And so that's for when you have daily and billing data. You know, it's fairly standard, a little bit simplified because you again don't have that many data points, especially when you're just dealing with 12 to 24 electricity bills. And so there's another model, this hourly model, that's used when you actually have interval data. And the hourly model approach incorporates a few different factors beyond just like daily average temperature. It creates a component based on the hour of week so that it can incorporate weekday versus weekend and time of day interactions. It creates a similar sort of temperature dependency, but based on your consumption in different bins. And it also does its own sort of guess at occupancy. So it actually creates two separate models, one for an occupied state and one for an unoccupied state of the building. And so you can see in this screenshot here, both an example of some of the information that you get in the audit report through the automated M&V process, which is we write out basically every step that we're doing and every detail of the calculation. And so in this example, it's showing the top graph is the prediction based on the model, and then it broken down by the component that came from your temperature dependency and the component that came from your hour of week. And then the following graphs sort of break that out even more. So it shows sort of what the model is predicting for every hour of the week and what the sort of the temperature to energy relationship is. And it's a little more complicated because they're interactive, but interacting between the two, but at least it gives you a general sense of sort of that building's relationship between time of week and temperature.
Excellent, and we can answer questions post on anybody wants to go deeper on that. But let me kind of wrap up kind of how we think about what the implications of all this are. So on the one hand is we want to think about this M&V going forward as somewhat of like a hierarchy where 90% of M&V can be done in an automated way, as Steve was just describing. It's the same kind of weather normalization, whether it's hourly or daily. We've got all the inputs that we need, and we just need to kind of churn through 100,000 buildings every night, and that's totally feasible. Then from time to time, there's going to be issues. Sometimes it's again kind of an erratic energy use pattern. Maybe there's some missing data. A lot of folks who are in the commercial space kind of understand non-routine adjustments, non-routine events can be problematic. So there's this middle layer of where we need some human intervention to kind of look at what's going on. And then, as Steve described, there's still kind of a lot of new technologies out there, a lot of ways at getting at what the underlying savings might be through custom methodologies. So we've a couple of years ago started the Open EAC Alliance to try to create a way for, it's not necessarily, in fact, it's not at all meant to be like a gatekeeping organization where like we're approving new methods or something like that, but rather new methods are going to be developed. They're going to be peer reviewed out there. There's no kind of right way of doing things in this industry. There's just better ways of doing it. And so putting this all out there in the public, getting feedback, and then being explicit about, hey, this is how we're doing things. It's totally documented. We feel like is the right way to kind of provide the discretion that the industry needs to the experts who know how to do this work, alongside the standardization that makes scaling possible. So, I didn't actually. I was going to get a real example of data quality. So this is one of the things that we ran into was with, I won't name names, but some of our automated data feeds from the utility data were not quite so reliable, and this stems back mostly from the utilities themselves, are still like terrible at sharing data for third-party uses. So we figured out that there might be gaps in that baseline data that could itself be predicted what the usage would have been if the gap wasn't there. And so we actually kind of built interpolation rules for missing data in the baseline that allowed us to fill in some of those gaps in a reliable way. But the kind of, again, the principle here is that those are documented. So if you've got gaps in your data that fit within the interpolation rules that we've put forward, we'll use those interpolation rules, fill in the missing data. Where the gaps are too extreme or otherwise, don't fit, the rules that we've set out, the project gets rejected. And so I think that's, that's kind of the theory behind this, is that we can create rules around how to do MV that allow for the automation to happen, allow for things like interpolation to happen. But again, making it explicit exactly what's going on with the data underneath. So from again, kind of circling back, where we still need the everybody's kind of worried about, this is my like token guy doing MNV AI image. Humans are still needed in the loop. Maybe just not quite in the same way that that we have been in the past, but there is this work of what are the anomalies that are happening? How do we adjust accordingly? How do we document non-routine events? So on the one hand, that kind of human in the loop in the MNV process itself. There's a second, as we're thinking about V2G, how do we do MNV when it's a vehicle to grid? What is the basis of the MNV that we're doing there? We don't really have great guidelines on what that looks like, and so we're going to have to come up with some new methodologies that capture the value of things like V2G or long duration storage, and some of these will be specific to the markets that are emerging. So being able to fit within a FERC 2222 ISO framework, so that all of these DERs can fully participate in the markets that are emerging. And then on the kind of backside, are we really getting this right? The utilities need to have confidence, if we're going to start treating these like grid resources, that the lights aren't going to go out. And so just like kind of making sure that the outputs here are robust and meet the kind of criteria that we would expect of our industry, again, is going to involve humans being engaged with this and participating and critiquing, and us, the royal us, not getting sensitive about that, like understanding that it's in all of our best interests to hold ourselves accountable and to continuously improve on the way that we're doing M&V in the first place. Okay, so kind of like big picture now, stepping like way out. I mentioned at the outset, data center, so we really need to scale demand side energy resources, and M&V is going to be a critical part of that ability to scale. The pressures on this are coming from data center. That's probably the biggest opportunity that the energy industry has to innovate in our professional lifetimes. Like what's happening today is not ever going to be replicated for, it hasn't happened since even like people like John have been in the industry, it's like that long ago. And those who are just starting out today will probably never see this again in their professional lifetimes. And so now is the moment where we need to think ambitiously about what's possible and how we can, deploy DERs at a scale that's going to be meaningful for this transition that's happening. We're seeing, I put FERC 2222 as an example, but there's, a whole host of demand side energy markets that are starting to emerge that will require credible standardized M&V in order for those to really be taken seriously. And then I think, there's backlash starting to emerge from communities around the country that the data centers are coming in and kind of taking away their, using up their power, using up their water. And there's an expectation now that actually what we need is something like a renewable portfolio standard, but for investment into community-based energy resources. So imagine that your data, that the data center company shows up in your town and says, hey, we'd like to plop down our 500 megawatt data center here. What if we turned around and said, okay, fine, but you have to procure at least 50% of your power from community-based energy resources, which is to say, like rooftop solar and storage and putting in heat pumps and all of the things, doing energy efficiency projects, so that the data center is creates value within the local economy, that it creates jobs, actual jobs within the local economy. It brings bills down for local residents and doesn't just extract all those profits and ship them off, to Wall Street or to Silicon Valley or wherever. So I think that to the extent that we can start making DERs, community-based energy resources, more measurable, we can start to unlock some of that value and use that as a way to mitigate those negative impacts of data centers and use it as an opportunity to move capital into this market. I'll say, and this is my obligatory train track picture, standards are still something that's really they're fairly poorly defined. If you look at demand response, just demand response, you can find 50 different demand response protocols around the country, from a 5 and 10 baseline to a 10 and 10 baseline to weather normalized, and it kind of goes down the line. We need to be a little bit more thoughtful about how we're setting out those standards. It's really hard to get consensus. I've been a part of multiple standards bodies trying to create some framework around this. I know it's hard work and it takes a lot of time, but it's important. And so the work that we're trying to do with the Open EAC Alliance is, again, kind of creating a convening space for industry experts to be able to contribute the methodologies that they're utilizing, that are currently being accepted somewhere, and to make them more repeatable, maybe to learn from each other's approaches. So that it's not just sort of like, somebody's doing this somewhere and somebody's doing that somewhere, but really, attempt to be more rigorous and systematized about this whole thing. So we'd encourage you all, we actually have an Open EAC Alliance meeting next week. Go to www.openeac.org to learn more, to participate in that, methods development process, to join the working group calls, and to, contribute where you possibly can. And then Steve and I obviously would love to talk to all of you. At WattCarbon, we provide free on-demand measurement and verification for any type of DER anywhere in the world. So you can go in and, as long as you bring your own data, so you have to connect, your, utility API account or, whatever data source you have, but you can, and select from one of the existing methodologies that we've built. But you can get, that kind of like automated real-time M&V, like in the platform. We charge you once you want to use that for some other purpose. But for getting kind of up and running, we want to make this as easy and as costless to you as we possibly can. So feel free to hit up me and Steve, me and or Steve, with requests for more information on that. And I think that is perfectly timed. 10:45. We've got time for questions. We can open up. I'll hand it back to you, John, to see this part.
Let's do it. Okay, so my number one question is, well, first off, Evo put out that non-routine events manual, right?
Yeah.
You know what I'm talking about.
I was part of that for a little while, I think.
Okay, so then you really do know it. So have you implemented any of those strategies, like the mini model, where you just take a regression of before the event and then you just use that model to estimate what the real usage should be if there's some aberration in usage or something like that? Are you doing NREs basically?
No, so our default here is like, I get why you want to do that, and it's going to be important for certain types of MNV where you're really trying to figure out like what is the cause, how much is this particular measure impacting the energy use, in this building vis-a-vis other things that are happening in this building. Most of the work that we're doing now is actually like kind of focused on the grid side. So how the grid views your building. And from a grid standpoint, an NRE is just bad luck for you, or good luck for you, depending on which way it goes. Because you think about, what a grid planner is doing is they're looking at it and saying, what do we think the energy use is going to be, across the population of all of our end uses, and they don't have any special insight into your NRE, right? They're like, and so if your energy use goes up or down erratically, that just creates noise, and so we're less confident in the savings that are being generated from. And so we'll put that, that'll show up, for example, typically in the CVR-MSE if it's in the baseline, and it'll show up as like an unusually high or low savings calculation if it's happening in the reporting period. But from the grid standpoint, it kind of doesn't matter what the cause of that is. It's just being documented, and if it's outside of the boundaries that are being set, then it gets kind of put into that bucket of like, we got to go talk about this and figure it out. But from a platform standpoint, the point we kind of take the perspective of like, we'll alert you to the fact that something is going on, but then leave it to kind of the contract to figure out what the right way of, and you do, this is the kind of thing you want to do manually, how you want to adjudicate whatever it is that happened there.
Just a little pushback. I would think that would be really easy to do in terms of software. I mean, you can identify when there's an anomaly. That's, I think, pretty easy to do. I mean, there's a gray area where you don't know if it's an anomaly or not. But when it's really a large, change, and maybe it lasts for several months or it lasts forever, I think you can identify that. I know your software can do that. And those mini models, where you just say, well, look, we've been tracking this for 2 years. So we'll just take the last 12 months of data and we're going to use that to say, look, this is what the usage should be. So we're going to do an NRE of this much. I mean, I don't know why you don't do that. I mean, I guess you explained it's because you're thinking more of the grid level, and I personally am more of a project level guy. And
yeah, it's just that's part of the trade-off is that when you introduce the human into the loop there, your costs increase exponentially. And so to the extent that you've got budget and like that's an important part of like if it's an ESCO, you're going to build that into your budget because that could be millions of dollars in contract value one direction or another depending on how that gets resolved. When you're doing 100,000 buildings across a large population, there's going to be a lot of NREs that are happening, and so you can't, to be able to. One way to think about this is if it costs you more money to figure out the savings than the savings are worth in the first place, it's probably not worth the time to go spend manually reviewing it.
Well, I thought that you guys could do it automatically, though. That was the thing, just employing the mini model method.
I was just going to say, another side of it is something we could do. Like we said that there's that whole list of methodologies in the Open EAC Alliance, and if a DER provider came up and we worked out with them and integrated into it, we could totally do that mini model. I think what McGee was saying before is it really depends on who's the report for, right? Who's the savings calculation for?
Right.
And if it's for the grid value, they aren't going to want mini models because they care about the observed. But again, if it is for an ESCO, if it is for these things, then yeah, totally. I mean, we can make up whatever, we can come up with whatever is the agreement is between the buyer of savings and the seller of savings is really what's most important. And
I like that you could do it as rules based, like you are. Just it's a rules based. We don't care about what, because all of us really are artists in a way when we do regressions. We all do it our own way, kind of. And when you do it rules based, you could actually do that with a lot of NREs, I think. Okay, so it sounds like then that you're not really that interested in doing these one-off projects for ESCOs. An ESCO might have, I don't know, maybe 12 to 50, 60 projects in a year, but that's not really your market. Does that sound correct? Or not a market you even want to explore?
We have a bunch of them work in our platform.
Oh, you do good. Okay.
Yeah, because it, there's still kind of, you get your weird stuff happening, but for the most part, most buildings, are, David Jump has that great article about, the good, the bad, and the ugly. Built, and like for the most part, they all work pretty great. And then you get a few that are like kind of weird, and you got to go deal with that. But if you can cut down 90% of your costs by automating, the ones that are good. So yeah, I think it's actually like, and then they come to us and say, hey, we need to control for like hotel occupancy. Like, okay, we can put that into the methodology, and then that's published. And now, like we just have the occupancy data coming in as part of the regression analysis that, that's, so it's like whatever they need to do to make the contract with their counterparty like feel like it's being accurately calculated. That's kind of like the configurability of the platform that we've built allows for that. Like one way to think about this, like just in our own story, like when we were doing the recurve work, it was like all had to be the same, right? There's like one size fits all for broke over and over again, because like one size doesn't all fit all. So when Steve and I kind of sat down to kind of design the WattCarbon platform, we started from the assumption that none of it was ever going to work. And so like literally, like we're assuming the worst case scenario, like so everything had to be fully audited. You had to know exactly why it broke at each step of the way, because it was going to break somewhere along the way. And then, but as a result of that, you end up with like a highly configurable platform that you can basically drop in any methodology that anybody agrees that this is how you want to do it. And you can automate that, so you can basically run any kind of, sort of custom methodology that you want to.
Okay, so I think you answered most of my questions. We got a whole bunch here. Let's see. One other thing is, let's say an ESCO wanted to do this. How long would it take to set up a meter? Let's say they wanted to add their own variable like school days. They look at a school calendar and they input school days. How long would it take for, let's say, a school district of 100 meters?
The meter says if they have the meter data already is like automatic, so that's maybe like 5 or 10 minutes.
Okay.
If you want to go like add a custom variable that we haven't implemented yet, that will take a little bit longer just to like put that into the code base and write the auto reports for that. But the kind of like fundamentally the point is like we can do on-demand M&V for any project anywhere in the world right now.
Okay, and then if they have, there's a lot of buildings that have SkySpark, and that's what I thought was really cool, is that you could take SkySpark data.
Yeah.
Okay, and it just automatically will just shove it in. That's great. And utility API is great too. Okay, so here's some other questions. When does hourly data make more sense than daily tracking, and vice versa? Assuming they're both available, that the data is available both ways.
I think I generally want to default to hourly because that's where the value is going to be found for the most part. And today, this is the idea of capacity. What time of day something is happening is almost more important now than the total volume of the savings that get measured. In fact, we actually hourize, that's the term of art, our daily data, our monthly data, using Comstock and Redstock models, so that even if we don't have hourly data, we estimate what the likely hourly load profile would have been if we did have hourly data, just so that we can have visibility into that time of day question. I think monthly, daily is a good way to understand. We do it a lot, like as a pre-M&V step, looking at your baseline, the relationship between temperature and energy use in your building, like understand what those underlying usage patterns are. The daily model is really helpful for that kind of thing, for assessing site assessment, thinking about what would we possibly save here. If it's already a pretty efficient building and doesn't have a lot of heating and cooling dependency, you don't want to spend a lot of money upgrading your insulation and HVAC because the savings aren't going to be there. So that's the kind of thing that you would get out of a daily model. Once you're doing the actual M&V, there's no reason not to do hourly if you couldn't.
Okay, so okay, for continuous M&V, what data do you actually use to build the baseline? How do you statistically verify the right data is being used to construct the model?
Steve, that's a you question.
So we'll be using we take a year of the building's meter data. There's questions around making sure that the project is part of the whole building and there's multifamily and all kinds of other caveats there. And we basically check to make sure that there's a full, at least a 90% data coverage for that year before, and then we use that to build the daily or hourly models. That answer the question?
Okay, I think so. Okay, here's another one. It appears that independent variables are degree days, occupancy unoccupied. That's you mentioned that on the hours, an hour of the day. Is that it, or is every job custom with other independent variables used? Yeah, so you mentioned changing the code line, so you can't just, there isn't something there where you can just press a button and just, suck in all this, data, and then you guys actually have to do real code changes. That means that costs money, right? If you want to do something like hotel occupancy or receipts at the, I don't know, something. You would have to, huh?
Yeah, I mean, there's this balance, right, where we're trying to come up with certain standardized ways to measure savings at scale, right? Because specifically for contracts, grids, utility marketplaces, things like that. But I mean, I think one of the things that we're lucky for is this would have been a lot harder a few years ago, but with like the advent of Claude Code and the fact that we've been doing this for a decade, we're not trying to make a custom methodology for every single project out there, right? That's custom M&V. But for certain additions like occupancy for hotels, and as we're building out and finding sort of some new methodologies to build, we're open to sort of adding them to the list. So we're hoping that at some point there's sort of a tail off of like when we'd be adding new methodologies, but we know that we're still not capturing all of the sort of more common.
So if you pick some hotel chain wants to work with you, you would add this new methodology, and then would you keep that methodology in the code where you'd have a check off, okay, we're going to do the hotel thing, and then the next hotel comes around, you don't have to redo the code. It's just
absolutely, yeah, and not just in the code, but we'd be writing it up publicly and putting it on the OpenEAC Alliance as a public methodology.
Perfect. Perfect. Okay, well. That's good. That's good. I like that. Okay. Is WattCarbon, you mentioned this kind of, but let's see here it again. Is WattCarbon a fee for service company? Are you charging service to set up, maintain, report, et cetera, on these M&V results? So you mentioned it was free to set up, but then depending on how you want to use it, then it might cost you money. Is that really complicated? Can you explain that fast or simply?
Yeah, so if you want to go put your data in, we've got a nice set of dashboards to like look at what happens, and then to get data out, you can generate reports, use our API. The reports API getting data out is basically like using it for commercial purposes. That gets charged a fee. Anything going in and like looking at it yourself and kind of understanding, how our stuff works, you can just do, and you just onto our website, sign up, connect your data, go to town.
So if I had 10 electric meters and I want to see a report, just baseline, what is it, adjusted baseline and actual data and the savings, what would that cost for a report?
Well, if you just want to see the dashboard report with the M&V and everything like that, that would be free. And so when we talk about reports, we're talking about building like custom PDF outputs for you to be able to share with your end customers or something like that.
And could you get Excel data?
Savings, it's all totally free.
Okay, what about downloading Excel data showing baseline and actual, like by months or by?
You want to send us Excel data?
Yeah, but what if a client wanted to get data from you? So use your tool as an engine, and now I want the data because I want to, I don't know, somehow connect it up to my own stuff I use.
That's where we charge you.
Okay. Okay.
Yep.
Okay.
And we have a pricing page, so it's should be pretty transparent exactly what
good.
its costs are. So it's just that's all on the website.
Okay.
Yeah. Based on the capacity of your projects.
Okay, here's one. I have often seen the price of automated M&V to be 20 to 30% of the annual energy savings. Anything over 10% of the annual savings is a big red flag. So question number one, how does automated M&V not hurt energy savings payback? Number two, how does automated M&V not hold customers hostage if they cannot pay the subscription? And number three, given these concerns, how do you sell automated M&V?
Yeah, I mean, we've really tried to innovate on the business model here. Again, a lot of the kind of these trade-offs are it's be automated, and so it'll be cheap. So it's way less expensive than what again, go to the websites. All the pricing is laid out there, so you can kind of evaluate that for yourself. But it should be in the neighborhood of like 2% of the value of the savings, not 20%.
No, not 10%. Yeah.
Yeah. I think it's unnecessary.
Yeah, I mean, there's a lot of engineering time people pay. At least the ESCOs, we spend a lot of time on people to do with this stuff.
Yeah.
Okay, someone made a comment about that I look really old. Well, that's because I'm not wearing my hat, so I look a lot younger, like this. We'll do that for the rest of the show. Okay, how much support does WattCarbon provide in the process of getting the utility data from the providers?
It's all automated, so you just drop in so if you've got like a utility API account, you'll have an API key from them, and so you go into your utility API dashboard, grab your API key, drop it into WattCarbon, and all of your meters and data download automatically. So we'll help if you need it, but there's not a lot of support required for that.
Yeah, so for all of you who don't know about it, utility API is a great way to get interval data. It's a great way. It's not that expensive. It's fantastic. And so they connect with it. And so you just need to sign up with utility API and then that'll work.
And Bayou and Arcadia, the same thing for all of those services.
Okay, yeah, I've only used that one. Okay, how does automated M&V compare to third-party M&V costs over its life cycle? Boy, that's a really general question.
I would say it's going to be way less expensive generally.
Yeah, I think it requires a general answer. Yes, yeah. Okay.
Depends on how much you're getting gouged by your third-party M&V provider.
Yeah, or you can say, well, it's exactly 82.3% less. That's exactly right. Has this been used in any ESCO project? Do you have any project-based demonstrations? Do you have anything on your website where you talk about like a case study where you work with an ESCO or something like that?
No, but we do have our registry, which shows for the projects that are being, kind of procured by third parties. A lot of this was for the early work we did around carbon EACs. But you can click in and see exactly all the M&V that was done for every single project that's in the registry. So that's kind of a good way of getting a feel for what those outputs look like. And then most of the ESCO work and that kind of stuff, it's pretty proprietary. It's sensitive, right? The data is sensitive, and you got to be real careful with that. Our blog, we've gone through and done some case studies of some different partners we've worked with. So we try to be pretty transparent, but also there's a level of trust here that you don't want to, expose people's businesses and that sort of thing.
Right. Well, I'm sure some ESCOs don't want those people to know they're using you because that's their competitive advantage, right? And so I got that. Can you please provide information about the next Open EAC Alliance meeting? The next meeting listed on the website was 8/21/2025, and the meeting is not listed on the linked Google Calendar. That's openac.org/p.openac Alliance meetings. So I guess they're not posting their new meetings there.
Yeah, that's on me and Steve, mostly me.
Okay. Okay. So can you update that soon?
Yes, next Thursday. It's in my calendar. Next Thursday morning.
So how are these folks going to figure out how to join if they want to come next Thursday?
They should sign up for the newsletter, and then they'll get emails when we.
Oh, okay.
Yeah, go to the. It's a Substack hosted blog. So if you sign up for the blog, then you'll get notified probably like today, because now I'm actually needs to do this. That there's a meeting next week, and we're going to talk about capacity methodologies next week.
Okay. Beyond the ideal option C case, how do you think the industry will justify the underlying capital expenditures in metering installation costs in order to enable and justify the automatic M&V paradigm shift, recognizing that the increase in installation costs comes with it in order to enable to capture data capability in such a way with data integration? Okay, back, there's a lot of, I'm trying to read this way. So acknowledging that not every meter required is a utility whole building meter, but all kinds of IoT local sensors or sub-meters.
Steve, do you want to, I can take it, but you probably have some thoughts on that.
I think the big picture is, again, it depends on who the savings calculation is for. We have different methodologies that vary across the different IPMVP options. So we have a fully deemed methodology that right now relies on sort of res.com Comstock load shapes for cases where there's no meter data available. We have the billing, if only billing data is available, we have that. We have interval data, those hourly models if you have interval data. And so I think the automated M&V doesn't necessarily require detailed metering. It's really more the contracts and the people who are procuring the savings and what their requirements are around how you're calculating the savings, because you can do a fully modeled approach, in an automated way.
Okay, are all the regressions on the platform linear? Do you use polynomial fits or anything else?
They are all currently linear because the regressions are all based on the OpenEE meter sort of LF energy work.
Yeah, okay. How do you deal with extrapolation? What if you have a year that's never gets really hot or never gets really cold, and then the following year it gets really hot and really cold? How do you deal with that?
Yeah, so I'm gonna kind of like put my foot in my mouth immediately. The new, there's actually a new, OpenDSM came out with a new version that we haven't implemented in our platform, but that's on our roadmap, that actually does do some, I think, polynomial fits on or exponential fits on the two edges to do like a little better at trying to capture extreme values that are going on. But so there's one thing that does, it helps it out a little bit, but the short of it is like that's a known sort of limitation of like the regressions, right? And of automated,
it totally is.
And just, that's something we were transparent about. It's especially tough with demand response because, right, or these cases where the reporting period is purposely the extreme temperature values.
Right, absolutely. I never really considered that. Yeah, right. Okay, let's see, here's another one. One of the existing methods, that was in quotes, does that mean a user has to pre-select? You do not have an algorithm to suggest the method. I assume by method you mean hourly or daily. What do you mean by methods? So it said one of the existing methods.
Yeah, so in methods, we really mean what kind of intervention, what kind of counterfactuals are you looking to calculate? Is really what we mean. So it's actually not, we do automatically based on what type of meter data you have, choose between the hourly or daily methods. But when we say you're choosing your methodology, it's really like, did you install a heat pump? So are you trying to get a counterfactual for whole building heat, gas, and electricity usage that's ongoing after a project date? Or are you doing DR and you have certain events? Are you trying to just calculate the savings due to load shifting? So you want to ignore shed, but you only want to count energy that's been shifted from one set of hours that's fixed to another set of hours that's fixed. And so there's a bunch of different ways to decide what your counterfactual is, right? Dependent on the project and the goals of the project. And so that's really what we need beyond the meter data. We need project information to be able to select. So that's why you're kind of selecting what counterfactual you're looking for.
Okay, one thing I noticed was you had as one of your options, you had linear regression, I think was one, or degree days or something, but another one was lighting. How do you handle that? What do you do?
The lighting methodology we currently have is like a device level one. So it involved, we worked with they got like a sampling of, they replaced a bunch of the replacing of a bunch of LED lighting in a warehouse, and they sampled a certain set of it in the reporting period that we then used to confirm the sort of controls level. Basically the two big things of the lighting methodology, one is what were the old lights, what are the new lights, right? That's an easy calculation. You reduce the wattage, and calculate that. The other piece is the difference in hours. And so the way most of that methodology revolves around a sampling method where they measured all the lights for like a month or two, I think, and then we extrapolate that to get sort of a control, like a number of hours differential that we then use.
So your software is deciding when the lights are on and when they're off. I mean, but it's looking at a whole building, so it's right, they're 30% on more or less, and maybe they're 40% now, and that kind of thing.
Yeah, but the meter data we got in this methodology, it requires like you sampling actual like individual light devices. They did like a full sort of sampling method to actually like instrument some of the lighting, and then on top of it a full list of all the lights that were installed. And so this was like a very detailed kind of methodology.
So then this is really just like an Excel spreadsheet, really, this method for the lighting?
Yeah, it could be. Yeah, I mean, we write it in code, but the thing that we reproduced was actually in an Excel spreadsheet at one point.
Okay. Let me see if I got any more. This might be all of them.
A gigantic Excel spreadsheet, because it involved 15-minute lighting.
Yeah. Okay. Yeah. Right.
Lights.
Yeah.
You heard
got them all.
that you said it's just an Excel spreadsheet.
Well, I just meant an Excel. But you're not actually monitoring anything. We just put in stuff before we monitored when things were on and off. We assume the on and off schedule that we had before is going to be there afterwards, and we just measured a lot of wattages before and a lot after. And then
no. There's ongoing metering.
There is. Okay.
Yeah, I think they just had. We have ongoing metering from the new lighting systems, but of a sample of the lights that are in it. They didn't like instrument every light with a sensor.
Okay.
But they, there's more details. It's very detailed, written up in the OpenEAC.
That's fine. No, and you're trying to describe it in very few words, and I got it. You can only do so much. I got that. Okay, so I think we made it through all the questions. Do you have any last words? Anything else you want to say before everybody leaves?
No, I'm 55 have stuck around for this to the bitter end here, and I just really appreciate everybody's time and would love to have the follow-up conversations. We're really excited about the work. A lot more to do, obviously, but this seems like a really promising, kind of step forward for the industry. So appreciate you having us on.
Yeah, I mean, look, it's just me. I'm just one man, but I sure would love it if you could implement an automatic NRE thing. Do the mini models.
Yeah, let's work on it.
Please do. Okay, thanks, guys. Thanks a lot. That was a great webinar.
Yep, thank you.
Thanks, everyone. See you all next month.